Okay, so having spent all that effort to construct the permutation generator, we now need a combination generator. At first glance, that actually might sound super hard because permutations, kind of the defining feature of them is that they're just like permutations except that the order doesn't matter, and yet if we're representing everything in lists, then the order has to matter. But there's a trick which actually makes this super simple, which is to say that we can take any ordering and just require that we only keep one of them, and that one ordering will be a representative for all possible orderings. So anyway, long story short, I basically just inherit all the same things that I did with the permutation generator, so that the combination generator is inheriting from the combination generator, but I just make sure that I keep only the permutations that are in increasing order. So if there's any other permutation, which is that has all the same elements but in a different order, only one of them of all the permutations with the same elements, only one of them is in completely sorted order. And so I will take that one to be the sole permutation, which actually is a representative for all of the orderings, and therefore is basically like a combination. Or at least there are just as many of them as there are combinations and so on. Anyway, so I basically inherit all of the methods with the sole exception of how do I generate the next index, and a lot of that goes very similarly. Except that because I don't want things out of order, then every time I increment this last object, I don't want to send it all the way back down to 0. Rather, I want to set it to, effectively, right? So here, where I would have otherwise set it back down to 0, instead, I'm taking whatever my most recent decision was for the end of the current index list, and the next one, because it always has to be in ascending order, the least one that I want to check is just one more than the most recent decision. And that's going to enforce that I always ever consider things that are in sorted index order. And that is really the major change here that kind of makes everything else happen. So that's how the combination generator works. And so since that is such a quick thing to describe, I'll also go ahead while I'm at it and describe how I built the multiset generator. Okay, so to describe the multiset generator, it's going to have different inputs. And in fact, in the previous classes that I've defined, I've tried to make it possible to give it objects that are not necessarily numbers. So like when you take the Cartesian product, I let you input a list of sets, and those sets could really contain any kind of element, in case you wanted some kind of more accurate representation of your particular example, which may not be numbers. So I did that with the Cartesian product. I also did that with the permutations and the combinations. But that just seemed like more work than it was worth, at least to me right now, when doing the multiset generator. So I really did kind of just enforce that this multiset generator is always going to basically have the elements of the set are going to be 0 through set size minus 1. So set size is some number. If it's 7, then we're going to be looking at the set 0 through 6. And then we're going to take the multiset size, which is going to be just the fixed size of the multiset as I defined in a previous video. And okay, so that's going to be the parameters of this class. And so I save these two sizes, right? I just store them into some fields. Now I also create a combination generator that I call star bar. And so, remember how we thought about the multisets as basically being identified with a stars and bars diagram. and it was effectively a word of length. This right here, it was, n plus k minus 1. N was the size of the alphabet. Here, the alphabet is the numbers 0 through k. But anyway, and then there was the multiset size k, and then minus 1. So and then we choose k minus 1 of them to be the bars, right? So effectively, this is just straight up using the combination generator to sort of simulate choosing the bars in, which characters in the word are going to be the bars, right? And so this is going to give me, every time I call next on this thing, it's going to give me a list of indices, right? Because it's going to be a list of numbers, right? Because after all, the set that I gave it is this list of numbers. So it's going to give me lists of numbers, and those numbers are going to be the indices in the word, which are going to be the bars. Okay, hopefully that makes sense, or maybe I can just keep going, and maybe it will make more sense as I go through the rest of the program. Just as before, I have this thing that is tracking whether or not I have generated the last possible multiset. Okay, so to describe how the next function works, it also has a property which is initialized to a trivial property that accepts everything. And I check to see while my star bar, right, combinations of indices generator has not reached the end, I generate the next one. The first time I call it, it's going to give me the 0 up to whatever the upper limit is. But in any case, right, so that gives me my first list of indices. And if it returned a none value, right, basically, right, every time I call next, I want to check to see whether or not that returned none. If it did return none, then I need to stop right there. Shouldn't be any more going on here, I guess. But anyway, okay. Otherwise, because this fundamentally is a representation of a stars and bars diagram, what I need to do is I need to count up so to speak, the number of stars that are in between each region segmented by bars. But since my representation is actually just a list of indices of where the bars are, then I need to do a little bit of math to calculate implicitly how many stars would there be in the corresponding regions. And so, that's what this does, right? So I take any given index, and I'm building that out incrementally, right? So whatever the first index is, right? Imagine that that first index was index 0. What that means is that the diagram starts with a bar, and therefore there is nothing to the left of it. And then, right, so the count of how many things go to the first item should be 0. So if that first index was 0, the count for the first item should be 0. If that first index was 1, that means that the 1th index would be where the bar is. There's a single star to the left, and so the count for that item should be 1. And in general, right, you can sort of see, I hope, that whatever that first index was, where the first bar goes, is actually the same as the number corresponding to the first item in the multiset. And so this out just gets initialized to a list containing that, and then I'm going to append to the list as I figure out all the other counts that go with all the other things. So how do I do that, right? So I'm going to iterate with I, taking on each next index value, and I'm going to append to this out object that I have created the difference between the indices, right? Because the difference between the indices is effectively going to represent how many stars would be in between the two bars at the two different indices. Once I have gone basically as far as I can do for that, the very last coordinate needs to get its own special sort of calculation, but anyway, having done that, out now stores basically the multiset, which, by the way, the multiset is actually just an association, or or sort of a positionally defined list, right? So like, you know, the first thing that's in out is the number, right? The quantity going to the first item in the set. And the second thing in the list is the quantity going to the second item in the list, and so on, right? So basically, out is a list of numbers, and the list is as long as, right, set size, basically. I hope that makes sense. So, so we check that multiset for the desired property. If it has the property, we return it. If we've made it this whole way and did not return anything, that means that we must have gone, right, like this thing eventually failed, and so we've reached the end, and so we set end reach to true and return none. I guess I could define a reset method, but I didn't feel the need, so whatever. Anyway, there is a description of how I generate all my multisets. And so in the next